Now, on Thinker, the numbers you see here are not just mock data. They're actually proven and there's evidence for it. You can view our benchmarks, our evidence pages on our website. Check out TriThinker XYZ. On the proof tab, check out too. Every benchmark we held or we conducted here, we have a blog on it. Talk about the AI latency, where we measured the time taken by each mode to um make decisions. We have reflex, the naive, the bypass, and then the cortex. We did all that and we logged them. We have the reflex in action, checking out how it handles retries of when there are faults. We have the adaptive bidding too, we have the failure taxonomy. We also have evidence like with actual transactions you can check on chain. When this graph was made regarding timing from confirmed to finalized for bundles, you can see the transactions that were used to conduct this experiment. You can check anyone on G2. Yeah, check it out. Solana, that should be SoulScan. Just view them on here. So for everything we said out there, there's evidence for it. Yeah. Yeah. And then coming back to the repo, we did a few things. We highlighted a few things like the we handled blood pressure with our own hold on. We have so you can read up on the readme, talked about back pressure, how we handle back pressure, where we have a different task for writing and reading. Read loop is not the same as the writes. So for things like writing to our life cycle file, make sure we push to the writes loop. The writer task, that's an unbounded channel that does that separately to avoid clogging the fast parts. We have our reconnection strategy too. Have them here, read about it here. And then we have our state surviving the gap, just in case there's reconnection time or reconnection issues. And finally, reconnect. Our in-flight tracking maps are held across the connect system. So make sure that our system is very robust to handle back pressure. And we also logged our engineering decisions whilst building this. Now, how do we confirm transactions? Now we use the Yellowstone transaction subscriber, but on the tip, not the bundle. We don't bother checking each transaction. We just check the tip. Since everything in the bundle is atomic, a bundle is atomic. If the tip has been processed or confirmed, means that other transactions too have been confirmed. So we check the tip instead of watching all the bundles with the Yellowstone TX subscriber. Initially, we were using the Get In-Flight bundle statuses by G2. That was pulling and not as efficient as streaming from the chain directly. So yeah, we dropped that and went on to use the TX subscriber. And then we use a rolling leader window, not the whole epoch. Initially, we started out with Get Leader Schedule, but I saw that it was fetching a 3 MB blob. And for a provider I was testing out then, he was failing for some reason. I don't know. The provider was severely its mid body. So I just thought of using the get slot leaders, which gets 5,000 per slot window. And then at the end, 500 left, we fetch the next slot window. So it's a rolling leader window. And it's faster, just in case the stream or anything drops, can always fetch and start. Unlike this, if we lose this body, we've lost our leader schedule. Yeah. And then we have in-memory queue. We didn't bother putting an in-memory queue from our dashboard. You can see that if you send the transaction and you restart the process as a sidecar to be dropped, because transactions take, 60 seconds, almost 60 seconds validity time. And say putting in the queue is just over engineering. I think so. Yeah, over engineering, because by the time you restart the sidecar, the transaction is almost expired. So there's no memory queue. If you restart it's not a bug. If you restart the sidecar, you lose the transactions because they might likely be expired when the sidecar starts up again. So there's no in-memory queue. It's a durability function, no bug, no need for that. Then we have uh wait for the next G2 leader and not the fallback transaction. Here, all validators don't run G2. So how about the blocks that are produced by non-G2 validators? And G2's format is that it can only send in bundles on their own validators or validator leaders that run the G2 infrastructure, that's G2 software, validator software. So how do we handle for blocks that are not G2 driven? We did our research. We checked, I think at epoch 974, no, at one epoch, we discovered that 97 or 97% of validators are G2 validators. So we most likely like 4 slots away from getting a G2 validator. So we didn't bother dropping into a regular send transaction because before you would run all that, there's a G2 validator up again. So it's very rare to not see a G2 validator. It occupies like 97% of the leader schedule. So we didn't bother setting a send transaction. Almost in less than 4 slots, you have another G2 leader validation. The leader validator, and you're up and running. Yeah. And then the two speed, I already talked about that in the AI video, why we built two speeds for first parts where you don't have to use the LLM every time, and we have the second one which uses the LLM on every submission. So you have to just pick your poison. Yeah, and we also talked about what we got wrong and how we measured our way out of it. I mean, we had issues, fixed them, and most of them we had to benchmark, do some take some measurements, comparing different formats and get this. So all these are available on our README. How we cut down to 3 cycles, right? We for our Synapse agent, which is in TypeScript. Yeah. And then the benchmarking, because benchmarking was using the script time instead of the sidecar. I had to fix that. So all that. Yeah. So thank you for staying to the end of this video. There's more about Syncar. You can check out the README, check out the website. Yes, you can read the docs and everything about Syncar. Yeah. So thank you very much.